Okay, then let's get started. It's 9:30 Pacific time. Happy Friday, everyone. Good morning, good afternoon, good evening, depending on the time zone you are in. Welcome to our 6th month into the YugabyteDB Friday Tech Talks series that we started this January. It is for engineers, by engineers, a weekly format, and it's my pleasure to welcome here today a longtime colleague and friend, Bryn Llewellyn. Bryn, why don't you go ahead and tell us a little bit about yourself and as well as what you do at Yugabyte.
Right, I'm going to be as brief as possible because I have given you a link to my life story. But I knew Kannan back in the early 90s, wasn't it? Early 2000s, when we were both in Oracle working in the PL SQL team. And then Kannan disappeared off to more fashionable things, and I plodded on. But eventually, after a couple of decades, Kannan recruited me back, and here I am in Yugabyte enjoying a whole new lease of life and having fun. And briefly, I'm not these days, and haven't been for some time, the kind of developer who writes C programs and gets them incorporated into YugabyteDB. My background is application development, writing SQL and stored procedures, and sometimes client-side programs like Python and that stuff too. So don't ask me about how things are built, but I'm very familiar with all the stuff I'll be talking about, especially because my major job these days is writing the accounts in the YSQL doc.
Wonderful. Thanks, Bryn. Why don't you go ahead and get into the topic of today's talk?
Right.
So all yours.
Okay, I'm now sharing the screen, and I'm just going to find my slides and make sure that you can see them. Can you see them?
Yes.
Right, here we go then. So just to show you I wasn't lying, if you want to know about my dull history, just click my name in the slides. So, and that's a general paradigm going through the whole lot. Now, I'll start with a bit of a waffle here, but before I do that, I want to stress that I'll be doing a lot of code demonstrations and flying through them at quite a rate of knots. And the aim is just to sketch the contours of what's going on. And I'm allowing myself to do that because I've prepared a zip of the whole shooting match, including these slides, and it's posted already as an attachment in the YFTT channel on the public Slack, the public Yugabyte Slack. So without further ado, now I'll get started. What is JSON? I expect you all know it, but I'm just going to go through it quickly. It stands for something that doesn't really resonate with what it's used for these days, but JavaScript object notation. It's a format for the serialization of hierarchically structured data. Objects within arrays, and arrays having objects as some of their payloads, and on and on and on indefinitely. And the standard here defines it or describes it just as a data interchange format, full stop. The idea is it's a kind of global export-import thing that can go between vastly heterogeneous systems as long as each end can either write it and read it. I've said here richly typed. You could perhaps argue about that, but as long as you're prepared to accept the fact that anything can be represented in a text essay, then you've got it. But critically, the standard doesn't define any operations. Now, it's usually called a document because it's represented as Unicode text. And this is its ultimate power of expression: primitive data type, string, number, Boolean, and mysteriously and miraculously, for anyone from any other background, null. Null is considered a data type with just a singleton value. And that can be tricky until you've got, until you've got your head around it. So there are also compound data types, and these are interesting. You can have an object, so-called, which is key value pairs, and an array of values. And the values, of course, can be any of these guys, including another object. And then you've got an array of values, and again, the values can be any of these things. And so it can go on indefinitely, deeply in a tree. So JSON in NoSQL and SQL. The whole business was first used in the early 2000s, so that's dating the whole thing. And this idea that it was an interchange format was rapidly kind of subsumed into something bigger, where it was used as the payload in key value pair schemes in various NoSQL environments. One of them in the later 2000s was MongoDB. Now, programming languages, you name it, brought libraries for constructing JSON documents, extracting values at various points along that hierarchy, concatenating things, comparing them, even editing them, all that business. And of course, parsing them when they come in. And PostgreSQL brought JSON support in this version, which was September 2012. So that's a long time ago now, well, a decade ago. Now, there are two data types, so-called JSON, which is hard to distinguish from when you're talking JSON-B. So I always call it plain JSON and JSON-B, but plain isn't the keyword. And then there are functions and operators on the values. And what Postgres does is implement the same general functionality that these client-side environments, and for that matter, MongoDB, have had for a long time. But it uses its own operator syntax and function names. Right, now here's a bit of a history lesson with a point. It was 1970, after Cod had been thinking for a number of years, that his seminal paper, Relational Data, blah, blah, the theory of relational came out. And then it didn't come immediately, but within the 10 years after that, the first commercially available relational database management systems came out. And then there was quite an epoch from 80 to 2005, a quarter century, when the RDBMS idea flourished. It was the only thing anyone ever did when they used a database for any purpose. But then, you've heard Kannan and others say this a million times, everything about scalability, blah, 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 blah. And so people had to say, well, this is all wonderful, but I can't use it because of the scaling and the fault tolerance challenge. So I'm going to throw away all this goodness and go back to the key value world. And that fashion was born, and it was incarnated in things you've heard of, like Google Bigtable and Apache Cassandra, and later MongoDB too, supporting JSON operations, as I mentioned, to let keys have rich compound values. But then, not long after that, Google, in their wisdom, said, well, this is no good. You know, it's just too hard working with all this stuff. And it's a poor substitute for Cod's time-honored wisdom. So what they did was marry the SQL ideas with the NoSQL concepts down in the plumbing layer. A good idea, but they had rather primitive SQL. And then, fast forward to now, missing out some of the history, Yugabyte has Postgres's actual upper half code for SQL processing on top of NoSQL's plumbing. You've heard that a million times. Now we're today, Yugabyte Inc., as I'm sure you've noticed, is thriving, and YSQL, its SQL subsystem, inevitably supports all that because of the code adoption principle. So the dilemma is this. That's why I went through the whole story of the history. Doesn't this lot make the fact that we've got JSON features irrelevant? So I'm going to address that theme.
Maybe Bryn, just wanted to make one comment. So I think like one comment and a question. I believe Spanner also recently introduced JSON around 2021. But I wonder if you remember when Oracle added JSON support.
When Oracle, it was sometime, I think in the mid-2000s, if I remember rightly.
Got it.
But I could be wrong about that.
No worries. Go ahead.
But we can always ask our old mates. So just to reassure you, I've given you references. All these functions and operators, here they are. I wrote this lot, it's good, and it's within an enclosing section on JSON, the whole total story, and therefore you can feel reassured that you don't have to remember everything. And if you want a quick chatty introduction to stuff, I've got a blog post on the topic. So enough of that, and now we'll move on to the real meat. And first thing I want to do is just show you some examples. And every time you see something like this, it's the name of a file. So I'm going to go over here, and there is the file. And I'm sitting in a place where that file is accessible to me if only I start up YugabyteDB. There we are, and as you can see, I'm as current as I had the energy to get, and it's on top of Postgres 11.2, I'm sure you know that. And this is a very banal program. All it does is establish a load of JSON B values, which I'll come to in a moment, JSON versus JSON B, but let's just leave it at that for now. And this is, you know, semi-complicated. It's got some nesting, and here's an array and so on. And sometimes I operate on it, and sometimes I'm just operating on straight manifest text constants. This is a table function. Don't worry about it if you're not used to this kind of thing. It's basically, here's some text, print it. Here's some text, print it. And because of this magic at the top, I'm here, sorry, this one here, return this. I'm casting the type text to the type JSON B. And if I just run that through, there we go, you'll see what I have here looks identical to what I have there. But there's a subtlety. If I just make a deliberate error here and put a single quote, sorry, I didn't do what I meant, put a single quote where I did have a double quote, perhaps that's a silly example because quotes and quotes are their own complexity. If I put a semicolon there, that's better, and run the thing again, you'll see it complains immediately. So what I've achieved subtly is demonstrate to you that all these things are legal, okay? And you can look more carefully afterwards, but they're just examples of some of the whole nesting notions. And interestingly, I'm using these techniques, JSON B casting to JSON B, casting to text from JSON B, and this operator, which I'll show you again now, this is just a foretaste of how you can go down within the structure and extract values. So enough of that, moving on now. JSON and JSON B, simple, don't use plain JSON, forget it exists, just use JSON B, even though the other one is available. This plain one just holds the text as is, merely checking that it's well formed on the way in. But this one, JSON B, holds a proper representation of the whole tree, which makes extracting things from it and doing various other operations on it much more efficient. And let's face it, that's what you're going to be doing most of the time, even if you don't think you are when you first start. So this, I've never measured any performance difference. There's presumably bound to be some, but I can't detect it. So I'll just show you what I mean here more vividly in file number 2. And what I've got here is something set up. This one and this one, though it's maybe not immediately obvious, have the same kind of concept. Keys called AA and BB, A and B, they're just in different orders. And then I'm casting it to plain JSON and casting it back to text from that, casting it to JSON B, which I'm calling parsed, and casting it back to text from that. And then I'm just asserting, so I don't have to clutter the screen with output, that what comes in is what came out in the plain JSON case. But in the parsed case, well, we'd better see what's going on. It's easier that way. And what we see is this is just maximally normalized. White space scrunched down to almost nothing, everything on a single line. Interestingly, the key order has been rearranged. That tells us that there's no semantic significance in the order of the key. It's just an associative array, if you like, where you can have a key in mind and go to it and find the value there. And the order of keys there and here is the same. And this is just a feature that I can't imagine you'd ever use in application programming, but it's great for understanding and especially for debugging. And the keys, what order is that? What person decided that the best order was to take the shortest and then alphabetically, and then the next shortest and then alphabetically and so on? This is the order that everyone else is used to for sorting alphanumeric strings. Yet over here, they've done it differently. Who knows why, but you just have to live with that. Now I'm going to make a very subtle point, but just so you know it's there. You can use this null thing for a particular key, or you can just fail to mention it. And with respect to the semantics of extracting, this, which is the way you get to that value, and this, which is where you get to it, even when it's not even there, they produce the same answer. They're both null. But surprisingly, these two JSON values themselves test differently. That can be a really nuisance in certain circumstances, and we might have time to see some of that. Now we're really ready to get started. Clock is ticking fast here, but I'm just going to put some JSON in and talk about it, create some indexes and constraints on it, test the constraints.
Bryn, before you go to this, there is one question.
Yes.
I'll relay that to you. The question is like, if folks want to retain the original JSON that's loaded, and maybe they're worried about this order of attributes getting changed and so on.
Yeah.
The question is it best, if that's the requirement, is it best to use JSON instead of JSONB, or better to just use a varchar and stick it into the varchar?
Well, I would say neither. You're not intended to care about the order. It's implicit in the standard. And life in programming is always like this. If you go against the stream, if you go against the intention, you'll end up in trouble sometime, sooner or later. You just have to accept that the order is not significant. What is significant is the interpretation of what it represents.
Fair enough. Keep going on. Yeah.
So then, here, in very short order, I'm going to create and populate a table. Then I'm going to put some indexes and constraints on it. And then I'm going to test for constraint violation. And I'll be using these extra features here, which we'll see in life, as well as extracting values down in the structure. So going over here then, this is number 4. This one is absolutely plain sailing, but I'll just enlarge it so you can see it. Maybe this is as big as it gets and still useful. I've highlighted one entire row within the set, and you can see by eyeballing the whole thing that, loosely speaking, there's always an ISBN, there's always a title, there's always a year, and the year is not a scalar. The year is an array of authors where each author itself is an object with given name and family name. Now down here, there's always some guy like Prince or Sting who resolutely hasn't got a given name. He's only got a family name. Well, we allow that, and I've represented it in 2 different ways. Here's Sting and nothing about his family name, and here he is with a family name, a given name, no. And correspondingly for genre, you notice eventually by enough eyeballing, or if you're lucky, someone wrote some external documentation, and there's even a formal way for doing that, to tell you that genre is optional. So let's just blast that one through. All we're going to do is see it come out again. Sorry, I did the wrong one. Kannan, you're supposed to be watching when I do typos.
Your font is a little small for me.
Yes. So this is yes. Well, I can make it bigger, of course.
No worries, no worries. I can see.
Okay, so I'll move on from that then. All we did was get back what we put in. Now, moving on to something more interesting then, constraints. If all this was represented relationally, there'd be nothing to talk about. But because it's not, there is. And basically, there's 2 parts of what we do. We'll create some indexes. This is fairly obvious. We'll have a unique index on the values at the end of this key, using this scheme of extracting them there. We'll have a non-unique index on year, because we're likely to want to sort by it and, you know, do within what's it called now, between queries. And then here, because genre is optional, well, we're having a partial index on that. And this is nothing more miraculous than the fact that these guys are expressions, and YugabyteDB, like Postgres, supports expression-based indexes. And whatever the expression is, well, it works fine. And in this case, they're JSON things. Here's a GIN index on the title, which is obviously going to be useful. And here's a gin index on the authors array, whose purpose I hope if we have time we'll come to see in a moment. Now the constraints, that's much more of a story. What we're going to do at the end is alter the table and put on a constraint which is expressed using a stored procedure. This stored procedure here. Sorry, the name of the procedure is here, this guy. And here we are creating it. It depends on a supporting type. And it's a huge essay, and I can't go through the whole thing, but basically I'm writing down here the fact that at top level, ISBN is expected to be a string, year expected to be a number, and so on. And genre might be a real string, or it might be this singleton data type, null. And similarly, at the next level, author keys, given name may or may not be there, it might be there as null, and family name is just a string. And then here's how we check that. Notice you couldn't do this in any sensible way except by using a procedure. I'm looping through. This thing pulls out the keys. I'm now looping through, and for each key, I find out what its data type is. I establish a record who combines those two, and then I search using classic array functionality, SQL array functionality, to see that the key data type pair I have in hand is one of the ones I've expected. And if not, then I eventually raise an exception. And that's the paradigm of this procedure. Either you get through to the very end and it returns true, or it raises an exception if something goes wrong. Just very quickly, by extension, it's the same approach down there in the authors, but you need an extra loop around the top because you've got to step through the arrays in the elements in the array. And for each of those, then you do the same walkthrough that you've been doing before. So now I'm just going to put this on. That was a mistake. I should have done it when I was talking, but never mind. Here it comes. Because it does take a bit of time. Meanwhile, I will move on to file number 6, which is just doing some constraint violation tests. And there's one for every thing I did, and I can't show you them all, but they all take the same general shape. I try to put in a document who I know is going to violate one of my rules. For example, this guy here, stick it in, and sure enough, I hope you can see that, I get the general error, and it says that my constraint's gone, this is the wording, and the particular thing that's bad about it is the authors can't be null. And then here are some more elaborate tests. Let's just try this one here. I'm checking that the family name is present always. And I've, of course, faked up a case here where Prince is good, but Sting, someone typoed him, and they said that Sting is his given name and he's got no family name. And there we have it. He's found this thing and said there's no family name in it. So this may seem a lot of typing, and indeed it was, but that is just the way you have to work when you want to establish that your JSON is something sensible and not just rubbish. Now the clock is running out now. I hope I can just show you some queries. Let's do this one here. This is a text query on the title. The index is already in place, and this is how you spell a text query, where I'm looking for title within that.
So here you're demonstrating the ability to gin index on JSON documents?
Well, no, I'm demonstrating the ability to use a gin index on ordinary text. And I extracted the ordinary text and created on an index on it up here.
Got it.
So sorry, not there, in number 5. Whoops, the clock is running here, but right at the top here, the thing on the text extracted that. So that's not so exciting as the next one, but it's not bad. And I'll run the test, which is this one here. Sorry, not that. I'm in the wrong file again. This one here. It's this. I've got it already copied in. I'm going to prepare it up. You can see how it's spelt. I have to do it relatively verbosely. But now I'm looking for books who've got time in the title. Sure enough. And now I'm looking for ones with that in the title, my contrary Mary, and I'm going to explain the thing. And arguably, this is the wrong answer, because it shows that in this modest 8-row table, we nevertheless used the index. But there's an advantage for me because I didn't have to stay up all night synthetically creating a million rows. So there's an example of those things. This other stuff is a bit tricky, but I'm just going to show you that it does work. I'm going to try to find records where Kernighan is in the authors array. And sure enough, it found it using this operator here, who you can read about. And then just to make it more usable, here I am preparing it up and then doing one use of it. Okay, I'm finding this thing, and then I'll explain how he goes about finding sting. And there we are. Sure enough, again, we're taking advantage of this gin index here. So that's all good stuff. Now then, moving on yet further, and now I think the time is really running out. I'm just going to, sorry, number 8. I'm going to show you here, just by running it, that you can transform that whole shooting match into a classic, old-fashioned, but still well-loved representation. And that's what's going on here. I've done the queries, and now we're on to this. You know that what you see conforms to this old-fashioned way of doing things. There are books, there are authors, and there are genres. And each book must have at least one author. Each author may be among the authors of one or several books. That's what's going on here. And then with genres, each book must be, may be of exactly one genre. It's possible there's nothing at all, but the genre may classify one or several books. And what I've done over here is just very rapidly convert the whole shooting match from the original JSON using all the features that are available, so that we've got a table of genres, a table of names, the basic table of books with its foreign keys to genres, and the intersection table between books and authors. And then using the magic of SQL, I've scrunched it all back down into a 1-row format where all the authors, this time as SQL arrays of SQL records, are presented that way. So that shows the duality of the two things. And now with the clock more or less at 0, I'm just going to say that the question is which representation meets your needs. I felt that I had really to set the stage before I could answer that properly. Now, you've noticed that dealing with JSON is frankly a pain. All that massive syntax and complexity, and even then some limited functionality. Now, if the incoming JSON adheres to a stable schema, as my example did, then I think, but not many other people do, that you'll want to shred it into a classic representation, get on with life there. And in this code that I've got for you to download, I also show you can go back from that to an identical JSON representation that you started with if you want to send it somewhere else. Now, if the incoming JSON schema changes periodically, or if a typical incoming document uses only some of the attributes, so that basically there's not much commonality between successive rows, but you want to have them all, and you want to be able to search on what you know is common, well, that's where keeping it in JSON comes to the rescue. But I don't know how common that is, frankly. The other thing is really people have an inertia from the old NoSQL world, and they can't quite yet learn enough SQL to start managing it in the classic fashion. There, anyway, is what we could call Dml Time Flexibility. But this is really the sweet spot where there's a big lump of stuff that is highly amenable to classic COD and date treatment. But there's other stuff that you just don't know how it's going to come in, and it might come in later. For example, you might want to record various reviews that people have done on books. Well, that's a perfect case for JSON at the end of the row that's got all the classic stuff in it. And this is my last point. There's a whole new world to talk about. I think it's the most interesting of all, but I'm leaving that as a teaser for you. Everything is there if you want to rush ahead, and do try it at home. So I won't even look at that. It remains only for me now to thank you and to apologize for being in a bit of a rush.
Bryn, thank you very much. I wanted to say a few things. I think the zip file that you uploaded to the YFTT Slack channel that somehow got deleted. So let's.
No, I did. I tried to replace it, and the replacement is lower down in the list of messages. That's just the feebleness of Slack.
Oh, wonderful. Okay. I also wanted to just mention a few points as it relates to this general topic, right? So I think relational databases adding support for something like JSON is a phenomenal development, right? Like, and it's not something that started today, like you pointed out. This has been happening since about 2010s, because it really gives you the best of the two worlds, like the hybrid conclusion that Bryn had, being able to still get the whole transactional, expressibility and power of relational databases, being able to specify constraints, use the full power of the declarative and expressive nature of SQL, but to extend that to even JSON attributes and leverage things like stored procedures and so on to enforce those constraints is a lot of things that been walked through. And so and Yugabyte, because of the nature of it reusing quite a bunch of Postgres code, the level of functionality we are able to bring to the YugabyteDB, it's really nice to see in terms of, and Bryn has used so many of those techniques in his demo. So I think great demo, Bryn, and great talk. The other thing is just that having all of these capabilities, but in a scalable architecture, including the indexing, being able to do indexes that are strongly consistent, global indexes, without having limitations like you might in MongoDB-like world, which is purely JSON oriented, and the support for consistent global indexing or multi-row transactions and all might be constrained within just a single shard, whereas in Yugabyte or a scale-up is really a scalable architecture. These constraints are global, and you can specify something like a unique index on an ISBN on a billion row table, and it just works. Is some of the things we wanted to highlight in this talk. But thank you very much, Bryn. Any closing remarks, and you can wrap up the talk from your side.
I'll close with just one thing. I didn't have time to emphasize it. You noticed in the JSON that there's what they call massive denormalization. Authors, like Joe Bloggs, who write many books, they were just repeatedly represented as the text, Joe Bloggs, and someone might spell blogs with only one G, and you're just out there lost. But any application that deals with that is going to want to let you pick the genre from a list of values. And if you don't find the genre you want, go to a special extra procedure to create one, on and on and on, everything that Cod and Date were writing about 50 years ago. And with JSON as your core notion for what is really a representation of relational stuff, you are just heading for trouble. But if you go for the sweet spot, and especially where the attributes of interest are scalar, then you've got the golden mixture, I would say.
Wonderful. Thank you, Bryn. And we'll see. Thanks everyone for attending the talk, and see you next week for
Thanks
another
again.
talk. Thank you. Bye.